Good morning, everyone. Today I'm going to talk about the anterior aspect of the brainstem. Sorry, the drawing was a bit small, so because this I had to move my camera down to zoom in better for this video. But let's move to the topic because it's a really interesting topic. The brainstem is probably the critical part of the central nervous system that connects the brain to the spinal cord, and it consists of three main components, which are listed from inferior to superior. Okay, so the first one is the medulla oblongata, and this one is the most inferior portion of the brainstem, and it is continuous with the spinal cord. It is continuous with the spinal cord, and it starts at the level of the foramen magnum, and basically the medulla oblongata contains vital centers for regulating functions such as breathing, heart rate, and blood pressure. Then we have the pons. Okay, we have the pons, which is located above the medulla oblongata and serves as a bridge between the medulla oblongata and the midbrain. And the pons is important because especially when we think about relaying signals between different parts of the brain, and it is involved in motor control, particular for facial movements and eye movements. When I talk about each one individually, will be much better to understand. And finally, we have the midbrain, and the midbrain is the most superior part of the brainstem and is involved in visual and auditory processing. There is also some relation with the motor coordination, but I hope that when I come back to this topic, I can clarify for you. And it contains important structures like substantia nigra, which you probably know is crucial for movement control, and usually is the area affected by Parkinson's disease. The anterior spectrum of the brainstem is mainly characterized by the emergence of the cranial nerves. As you can see here, I wrote down all the cranial nerves, and they are responsible for sensory and motor functions. And I would like to cover each one here, starting with the optic nerve. Okay, the optic nerve, and the optic nerve is not directly attached to the brainstem, but emerges near it, and it will carry visual information from retina to the brain. When I talk specifically about this nerve, you will have I believe that you will have a full understanding of the function and the clinical aspects of this nerve. But just to let you know that damage can lead to vision loss or blindness. The optic tract, which is this part here, is a continuation of the optic nerve, and here will be transmitted visual information to the visual cortex. Usually lesions can cause visual field defects, and this topic is really interesting actually. But I'm gonna leave this for the next video. Then we have the oculomotor nerve. The oculomotor nerve, this here, okay, is attached to the midbrain, and it will control most of the eye movements, and it will also regulate the pupil size. Usually damage results in ptosis, which is the dropping of the eyelid, and it can also cause dilated pupils and impaired eye movement. Now we have the trochlear nerve, this one here. And the trochlear nerve is attached to the midbrain, as you can see, and it will innervate the superior oblique muscle, which controls the downward and the inward eye movement. Injury causes double vision, which we call diplopia, due to the impaired eye alignment. Then we have the trigeminal nerve. Okay, trigeminal nerve. This one is attached to the pons and will provide sensory innervation to the face and will control the muscles that chew. Sorry if my pronunciation wasn't the best. Now, the trigeminal nerve, there is a clinical information that might be very relevant, such as trigeminal neuralgia, that is severe facial pain, and the Bell's palsy, that is the facial paralysis that usually affect this nerve. And then we have the abducens nerve. Abducens nerve. Let me just think. Now that I saw that I wrote abducens nerve better. Okay, so this nerve is attached to the junction between the pons and the medulla, and it will innervate the lateral rectus muscle, controlling the outward eye movement. Usually damage causes esotropia, which is the inward turning of the eye, because if you don't have control on the outward movement, the eye will move inward, and double vision. And then we have the facial nerve. The facial nerve, which is here, okay, facial nerve here, is attached to the junction between the pons and medulla oblongata too, and control facial expressions and will provide taste sensation to the anterior 2/3 of the tongue. Bell's palsy is a common condition caused by inflammation or compression of this nerve, which leads to facial weakness or paralysis. Let me just move downward. It's better? I hope so. Then we have the vestibular cochlear nerve. Okay, so this one is attached to at the junction between the pons and medulla oblongata, as you can see. So basically at the junction, vestibular cochlear nerve, facial nerve, and also abducens nerve. But back to the vestibular cochlear nerve, this nerve is actually divided into two functions. One vestibular and the other two vestibular and the other to the cochlear branches. And the vestibular branch will control the balance, and the cochlear branch transmits auditory information. Okay? Because this is the name vestibular cochlear nerve or vestibular nerve. And then clinically, when damaged, can cause vertigo, hearing loss, or even tinnitus. Now we have the glossopharyngeal nerve, which is this first part here on the top, attached to the medulla oblongata, as you can see here. Now all the nerves are attached to the medulla oblongata now, and it provides sensory innervation to the throat and taste sensation to the posterior 1/3 of the tongue, and is also involved in swallowing and saliva production. The glossopharyngeal neuralgia usually causes severe pain in the throat and the ear area. Now we have the vagus nerve here, as you can see, also attached to the medulla oblongata. It's the major parasympathetic nerve that controls many visceral functions, including heart rate, digestion, and the vocal cord movement. The vagus nerve stimulation is used to treat epilepsy and depression. Damage usually causes affect the swallowing and the voice quality. And then we have the accessory nerve right here that is attached to the medulla oblongata as well, and it innervates the sternocleidomastoid and trapezius muscle, which are involved in head and shoulder movement. Injury causes weakness in turning the head or shrugging the shoulders. And the final nerve is the hypoglossal nerve attached to the medulla oblongata, and this one here controls tongue movement, and it will be essential for speech and swallowing. And damage caused dysarthria, which is speech difficulty, and dysphagia, swallowing difficulty. So these are the main nerves composing the medulla oblongata, pons, and midbrain. Okay. If you liked this video, don't forget to hit the like button, subscribe, make a comment, and I will leave you a very short quiz here, which is number each one of these nerves, okay, and write in the comments. So see you next time.